instructor here is asking you to solve these equations, and it says to show all inverse operations. What they mean by that is like when you undo, so you don't do it that way anymore. When you undo addition, you undo it with subtraction. You undo subtraction with addition. So like here, there's subtraction. Do you see that?
Mm-hmm.
So you undo that with addition by 7. Did you see that in class?
Yeah.
Okay, so y equals 5.
Yeah.
Now there's this thing here for the check, and I don't really know what the instructor is expecting there, but I think it's like if you undo what you just did, so like you have y equals 5 here. If you subtract 7 and subtract 7, do you get back to the original?
Yeah.
So y minus 7 equals -2, and you do.
Yeah.
Is that okay? Clear?
Yeah.
All
Yeah,
right.
it is.
Okay, so let's do the next one here. All right, so here you're going to undo addition first. So you're going to subtract 5 from both sides of the equation. So this is 3r plus 0, but you don't write the plus 0. Like you want to get you actually want to write this line here is what you really want to get to. You want to be able to go from these two lines down to this one. You don't necessarily want to write plus 0. You follow that?
Yeah, I do.
Okay. Okay, so now how do you undo multiplication by 3?
Do you do division?
You do division. So again, I'll write this one more time, but it's basically these two and these two. So you divide by 3, use a fraction bar to show division. And then you get r equals -6.
Yeah.
All right, so now the check is where you take what your final answer is, and you undo all the steps. So instead of dividing by 3, you multiply by 3.
By 3. And
So
then
you
that
3,
should get you to the normal equation, right?
and then you undo subtraction by 5 by adding 5 to both sides. It's a little weird because you just
Yeah.
it's going back to the beginning, but it once you do a few of these, you get it.
Yeah.
All right. All right. So letter C, a new equation here. And this is a homework assignment. Is that right?
Oh no, this is old work. I just like didn't really understand it.
Okay.
Well, it's like, yeah, it's like old work I did.
Got it. Okay. So here, I want you to try this one on your own. You're going to undo this first, this +3, and then you're going to undo this one right here. And I'll help if you have questions, but just at least give it an attempt here. You know, 30
Okay.
seconds to kind of think through what you might do on this one.
Do you do the 3 you like
You want to
minus?
yes, you want to subtract 3 as your first step. So as I mentioned, like you're going to get 0 here, but you don't really want to write this. Like I know I'm writing it here, but really you want to say, oh, the 0 just goes away, and this equals 5.
And then you do 5 minus on each side, or
No. You're undoing this 1/4. So this 1/4 is multiplying this. Okay, so I see the problem here. I think I understand what's confusing here. So you're going to multiply both sides by 4.
oh, okay.
Okay, and then we're gonna have to do a few examples of these separately. So n equals 20. So your check, you start with n equals 20.
Oh yeah, and then you do the adding 3.
Well, you
Right.
start with this one right here. See how we multiply by 4?
Yeah.
So you want to divide both sides by 4.
Oh, okay. So you divide both sides of 4. Then you add 3, right?
Well,
Or you,
because you subtracted 3, so you want to write your line, but then you're going to add 3, so it's n over 4 plus 3 equals 8.
yeah. That's what I meant. Yeah.
Okay, so what's happening here from my perspective is they're giving you a bunch of different types of questions, and all of these fall under the category of solving one-step equations. One step, and then it moves to two-step equations. And I think we need to have an understanding of like what it means by solving a one-step equation. So let me give you a quick question here. How do you solve this equation on the left? How do you undo subtraction by 7?
So you add 7
You
on
add 7,
the
okay?
sides, each side.
And you have n equals 5. Now let me give you another example here. Let's say it's r plus 2 equals 5. How do you solve this one-step equation?
You minus 2 on each side?
You subtract 2. You always undo the operation. That's what it means by inverse operation. Okay. So now let's look at another one here. Let's say it's 4x equals negative 20. How do you undo multiplication by 4?
Dividing
So you divide both sides by 4.
by 4.
Okay, I'm sorry, that's negative 5. So as a small variation on this, sometimes they say x divided by 3 equals negative 6, or they can write this as 1/3 x equals negative 6. These are the same, but they maybe look different to you, depending on how your comfort level, but they are exactly the same. They're both division by 3, so you undo it with multiplication by 3. So on the left, it cancels. It always cancels on the left. Same thing here. You get x equals negative 18. So if you understood what I just did, and I think you do,
Yeah.
the solving one-step equations isn't your problem. It's these two-step equations, which is what we started working with in B and C.
Yeah, the one steps don't really confuse me. I think I got the one step problems really good.
Okay, so let's try another one. Let's say it's 2x minus 7 equals 21. Okay.
So you add 7 on 7 and
Yeah.
put,
So when you're doing when you're solving, you work backwards, meaning you undo addition and subtraction before multiplication and division. So you add 7, and then you get
then you
2x,
2x 28.
and then you divide by 2 to get x equals 14.
13. Yeah, I get that. Yeah, I got it.
Great. So let's try one more here. Let's try 1/5 x minus 3 equals negative 5.
See, the only thing with the fractions kind of throws me off.
Understand. So we did one just like this though. And like you can think of this as multiplication or division, but what's the first one you're supposed to undo?
The 3 and the 5, so 3 plus
You're
3.
supposed to add
Yeah,
3,
add 3
add
each side.
3. And then we proved earlier that you are more than capable of doing this one.
And then you do 2 times on each side.
No. Let's go back. Let's go back here. What did we do? What did we do here in this x over 3 and 1/3 x? What did we multiply by?
The bottom number.
The bottom number. So same thing applies here. What are you going to multiply by here?
5.
Bottom number. Yeah. Okay. Let's do another one. Okay. Let's
Okay.
do another. So let's say it's 1/6 x plus 4 equals negative 3.
So you do the 4 minus on each side, right?
Subtract 4 from both sides. I agree. Got
And
it.
then you put the 1/6 x down with the
Good. Okay.
say -7, and then you do 6 times on each side.
Yeah. So you have to remember what you just said is you always multiply by the bottom number
The
there.
bottom number when you're doing the fractions.
Yes.
Okay, got it.
Okay. Let's now look at question D. It's unfortunately D is like it's like another step or what I call a level to these types of problems, and it's not necessarily more difficult, but you have to, until you've done it, you're not sure what to do. Do
Yeah.
you recall whether you distributed this 2 to both of these? Do you remember that?
Uh,
Or do you see that now? Like, do you say, oh yeah, that makes sense, Matthew. Let's distribute the 2 into both.
I think we could just distribute it.
Okay, so this is like 2 times 3v plus 2 times 1 equals 44. Do you agree with that? Do you see
Yeah,
how, so you have to give it to both?
yeah, it's like the same
Okay,
thing.
so now we're going to simplify and we're just going to multiply. So it's 2 times 3, 6v, 2 times 1, 2 equals 44.
Yeah,
Is that okay?
yeah.
All right. Now this line right here is just like the previous problems we were doing. You have to undo the addition, and then you have to undo 6 times v. So go ahead and try solving this on your own from here.
So you do the 2 minus the 2 on each side.
Good. Good.
And you bring that down. Then I'm not sure on this, but you multiply the 42 on both sides.
Okay, so let's go back. You've done some like this. Let's go back and look at one that you did here, like 4x equals minus 20. What did you do here?
We oh yeah, we divided both sides.
By what number?
The 4,
Why 4? Why not 20?
because it has the x.
Yes. So for some reason, and it doesn't really matter why, but you're focusing on this number over here on the right, and you did that over here, like on this one of these earlier ones. That number is irrelevant. Your focus needs to be over here on that,
Yeah, on the v.
on the whatever the letter is. Yeah.
Yeah,
So you're going to divide both sides by 6, and v equals
7. Okay, yeah. Let me practice another one of those.
sure. Okay, try solving that one, please.
Okay, so we add 3 on both sides.
Okay. I'm going to let you go through this one on your own. I won't write it down yet, just to see if
Okay.
you can get caught up here on understanding these.
Okay. Wait, what is a negative 28 plus 28? I kind of forgot.
What are you adding to both sides of the equation?
Oh, I mean 3. Oh my gosh, why am I thinking 28? 3, yeah. Oh, never mind. Okay. I don't know why I thought 28.
You're still focusing on this number, and that's okay, because we're talking about trying to learn through it, but everything we're doing has to be from this other stuff over here.
Okay, I think I know. Okay, I think I got it. Like, not the answer, but I'm really close. Okay, I got it. So we add 3 on each side. Oh
Yep,
yeah.
you got it. Okay.
And you get the 5x and the 25, negative 25, and then you divide both sides with 5 and you get negative 5.
Excellent. All right, now I want to move on to the next section. I don't think you have like 100% grasp on this, but
Yeah.
it's something that you can get better at. But I want to make sure we get through everything as well.
Yeah.
So some of this stuff is we'll just continue to build on this that we just did. So I'm moving on to 2A, this inequality. It says the instructions say to solve. Okay, yay, solve. Okay, and maybe your instructor said this in class, maybe they didn't, but you treat this is like, and if you need to, this is like an equals. So if you need to, you can actually write it as an equals. I don't really want you to do that, but that's okay if you want.
Okay.
So now, how do you solve this equation? Well, it's actually no different than what we've been doing before. You have to undo addition and subtraction, then multiplication and division.
Yeah, so you do 16 minus on each side.
Add. Why add?
Yeah. And then you get that. And then you do 5 divided on each side.
Yeah, so D equals 6. Okay,
Okay.
but, and this is a big but, okay, big but. It needs to be this symbol here.
And then you put that symbol there.
Yes. Okay, so like if you write the equal sign, it's like opening a door. If you make a change, you need to close the door.
Yeah. Yeah, I'm getting this. Like, yeah, it's making a lot more sense now.
All right, we're actually going to go to part C next. Okay, so this one could appear different. The variable is now on the right, but you undo addition and subtraction before you undo multiplication and division. Okay, so see how there's plus 12 here?
Yeah, I do.
Well, how do you undo addition by 12?
Mine subtract 12.
Yes. So you had 15 less than or equal to 3x. How do you undo multiplication?
Division.
By 3, division by 3. So you get 5 less than or equal to x. This is correct, but wrong. You might say, what do you mean by that? That sounds, the problem is that the variable needs to be on the left. Variable on left. So I'm going to flip this, x greater than or equal to 5. Do you see how this thing right here is pointing to, well, you could say it's pointing to the 5 if you want. It's still pointing to the 5, but we read this is read better or preferred. So I'm using a lot of words to basically say the variable needs to be on the left. So you solve it as if the variable's on the right, like you did here.
And you
But
always move it.
you have to, but you don't just, it's not like I just change it. It has to, the orientation has to be the same. It's like if you see this pointing at the number, then it needs to point at the number.
Yeah, when that switches, then the
Yeah.
other thing switches.
And this is read as x is greater than or equal to 5. That's how it's read. You have to have that there.
Yeah, I remember that from class.
Okay. We're doing B last. It has like a little, I call them wrinkles. What you need is more practice of like type A and then type C and then type B, but your class doesn't have that. And I'm seeing that as an issue here. This has another additional wrinkle to it. So we talked about the idea that you can just make this in equals. Do you remember that?
Yeah, I do.
Okay, so this one's different though. What is the sign of 12? Is it positive or negative?
Positive.
Positive. Okay, and this is another variation on these questions you've been doing. This is the equivalent of adding 12. It has nothing to do with this symbol here. The operators always go to the right. So this negative has nothing to do with this number here.
Yeah.
So this is positive. How do you undo a positive? And I'm basically asking you, how do you undo addition, which is
Subtraction.
subtraction? So you subtract 12 from both sides. Minus 2w, because it goes with it, equals -4.
Yeah.
Okay, so now you divide both sides by -2.
Yeah.
And w equals 2. Okay, again, there's a but though, and I hate giving all these exceptions, but like 80% of math
And then we
is,
got to do the greater than thing, right?
well, here's the issue though, is do you see how you divide it by a negative?
Yeah, I do.
Every time you multiply or divide by a negative, you have to flip this.
Yeah, I remember that.
So this, because you did it one time, you flip it one time.
Okay, so then yeah, it goes backwards, and then you got the greater than. over
Yes.
W.
All right. Now we didn't do this part, but we're gonna do it for each of the letters now. So A, when we were done with A, we got D greater than or equal to 5. Okay. And your instructor says to graph this here. So we're going to graph this. Here's a 0 on a number line. 1, 2, 3, 4, 5. So here's some things to remember here. If it's greater than or equal to, less than or equal to, it's a filled in bubble. You remember that from class? You remember seeing that?
Yeah, I
Remy?
do.
Remy? Okay,
Yeah, I
great.
do.
Okay. All right. So then this tells you, this means you're going to go to the right, and then this is to the left. So you're gonna shade everything to the right of it.
Mm-hmm.
Remember that from class?
Yeah, I'm pretty sure I was pretty good at that.
Okay. B is W greater than 2. So we're gonna draw another line again. Here's 0, here's 2. If it's less than or greater than, it's an open circle. Actually, let me reorder these.
It would go right.
Say that one more time.
It would go right.
Yes,
Like,
but you have to make it very clear that it's an open circle. You have to overemphasize it.
yeah, because it wasn't. It didn't have the line under the.
That's right. That's exactly right.
Yeah, I
And then
remember.
part C, we got X. Let me scroll up and see what we got. We got X greater than or equal to 5. Oh, the same thing. That's odd. Oh, this was 6. I'm sorry. I gave you the wrong one there. Let's put 0 right there. So the last one was X greater than or equal to 5. So it's the same deal there.
Yeah. So you go to 5 and then closed circle. And
Perfect.
Then the 5,
Yep.
right.
Very good. Okay.
Yeah.
All right. So we're going to do 3A. All right. Isabel wants to earn at least $70. So the word at least is this symbol.
Okay, greater than, less than.
Yep. At most, you might see that as less than or equal to. If you see more than, it's that one. Less than, it's this one. So there was a time or a class, or at some point you converted sentences into equations. It was like a number plus 3 equals 5.
Yeah.
It's the same thing here. You have to know that the words correspond to these symbols.
Mm-hmm.
And if you can't do that, then you're going to really struggle. So that's why I'm writing it out like this, so that you see that. So Isabel wants to earn at least $70. So this symbol right here is read as at least, and that's $70. Okay. She starts with 22 and earns $8 per hour.
Yeah.
So the idea is that, like, this is what's called the fixed, or the starting amount, and then this is the increase.
Mm-hmm.
All right, so now that's part A. We need to solve it. So this 22 is positive. Do you see that?
Yeah, I see that.
So how do you undo addition by 22? And it's not because of that symbol, it's because of this plus right over here.
Subtraction.
Subtract 22 from both sides. So
And
that's,
drop the H down, and then you
yep.
get 48.
Okay. And how do you undo 8 times H? I heard divide, I think. Excellent.
Yep. Yeah, it's all like the same thing.
It is, but it's do you recognize that in the moment? Like math, it's not elegant. Often it's the same thing, but just presented a different way. Same thing.
That's what really confuses me and gets me, is just
So,
presented in a different way, and for some reason my brain just kind of like doesn't like think it's the same thing.
you have a chance to change that, though. You have a chance to say to yourself, Matthew told me that like this worksheet, I'm just doing the same thing over and over and over again. So when you get to your worksheet tomorrow, like, or whatever, next time you have on, like, try to say, well, can I remember that? Can I remember that? This is like the same thing. So what did I do in the previous problem? And it is the same thing here. Okay, now we're supposed to graph it, and you said you're really good at that. So go ahead and graph it, and then I'll show you my graph, and you can tell me if you agree.
Okay. Well, I already know, really.
So I'm asking you to make a graph there. I mean, I can't check. I can't
Oh, okay.
make you
You'll
do
do
it.
like a rough graph on
I'm
my
asking you to do this, and then I'll do it, and you can compare your result to
Okay.
mine.
Okay.
So here's my solution: 0, and then 1, 2, 3, 4, 5, 6, filled
Close.
in circle, and then to the right.
Yeah, that's exactly what I did.
Okay. So let me ask you: is 7 okay? Is 7 a true solution?
Uh-uh.
Why do you say that? Give me some more information.
Because it's not h is not greater than less than 7.
Well, but h is greater than or equal to 6. That means anything
Oh
bigger.
yeah, then yeah, 7 is.
7 is, how about 8? Is 8 okay?
Yeah, 8 is okay.
How about 9? Right.
Everything till the end or whatever is okay.
Here's what I just heard. You said everything bigger than 6 is good. So 6, 7, 8, 9 forever,
Yeah,
right?
that's right. Yeah.
Well, part B says, is 5 okay?
No.
I agree. So how do you know? And they're looking for words like less than, greater than. What kind of words could you
5
use
is
there?
less than 6.
5 is less than 6. Yeah. Great.
This makes sense now.
Awesome.
I definitely could do really good now on the tests and stuff with this stuff.
All right. Let me all right, let's do one like this on coming from the other worksheet. I want to get through these, and then we'll do some more solving 1 and 2 step equations to make that clear. All right, so Kiki wants to have 30 keychains in her collection. Sorry, this is not okay. Kiki wants to have 30 keychains in her collection. So that's not very clear, but that means at least.
Yeah.
Like, she's happy if she has 30. So at least is this symbol right here.
Mm-hmm.
She currently has 9 and gains or increases 3 more every week.
Yeah.
How can you write that over here on the left? And it's very much the same as what we did in this previous problem. You have something you start with, and you're adding to it each week. So see how this was 22 plus 8 variable, 8 times h. Here you have 9, and you gain 3 more every week. So I'm kind of asking you here to put what would you put in this box based on this right here?
9.
Okay, anything else?
And the 3 for every week.
So give me more information here. Like I need some more words. Is there a math symbol here that you can think of?
There's the greater than less than.
We already have that. So let's go back and look here. What did I write here? Read this out loud to me, starting here.
positive 22 plus 8h.
Right. And I got that from this 22 and 8.
Yeah.
So the starting amount was 22, and I'm adding, the and is like the plus. The
Yeah.
8 is the 8, and the H is because it's in hours.
Yeah.
So I'm asking you the same thing here. Like I can't just write 9 and 3. I need a math operator between them. What is that math operator? What does the and correspond to?
Oh my gosh, I keep going blank. The variable
Plus.
or whatever.
Plus. And is like a plus.
Yeah.
Okay. And then 3K keychains per week.
Yeah.
Okay. So let me just write this inequality. And I want you to solve this on your own, please.
Okay.
Give that a try for me.
Gotcha. Wait, is the shoot? I'm kind of confused. Is the 30 go under the 9 or 9 go under the 30?
Well, let's look back at this one. What did you do to solve this equation? What was the first thing you
Okay,
did?
I got it. Yeah.
Do you see how I'm answering your question by saying, what did you do before? What did you do
Yeah,
before?
I would look at that. I just don't like have it in front of me.
But what I'm trying to get you to see though is that like you can do this. You absolutely can do this. You just have to go back and say, what did I do before?
Yeah.
Okay, so what are you going to do here at this step? 9 plus 3K.
Okay, I got the answer.
What is your answer?
7K greater than or whatever. Or no, but it flips around because we divided, right?
Not by a negative.
Yeah.
So give me your final line here. That's what I'm asking you.
So I did the like the greater than less than like the K, then that, and then the 7.
Yes.
Okay.
All right.
Cool.
All right. So I'm seeing so I do kind of want to go back to solving these two-step equations. Okay.
Okay.
All right. So there are there's only a few different kinds of these. There's the type where you first add, then you divide. Okay. And for an example of that is 2x minus 7 equals 13.
Mm-hmm.
Why do you add first in this problem?
You add first in the problem because it's subtraction.
Right. So you add 7, 2x equals 20, and then you divide.
I need a 10.
Okay. Now there's also problems where you add and then multiply. So let me show you one of those. 2x plus, I'm sorry, 2x minus 6
Then you do addition.
equals 4.
And then you do addition on that because it's subtraction.
Right. And you get 1/2 x equals 10.
And
Why do
then
I
you
multiply?
wait, what? Why do you
Why do I,
multiply?
yeah,
Oh,
why do you
because
multiply?
we originally started with division.
Yeah, it's because it's a fraction there. So you get x equals 20.
20.
Okay. And then there's the next one is you can first subtract and then divide.
Yeah.
Okay, so let me give you an example of that. 2x plus 3 equals 7. So what are you first going to do?
You minus the 3 on each side, and then you 4. You get the 4, and then you divide each side. You get 2. X equals
Yeah.
2. Yeah, this makes sense.
When there's one more. There's one more here. Okay. So there's one more. There's subtract and then multiply. So let me give you an example of that. 1/3 x plus 5 equals 10.
Yeah.
Okay, so you're first going to subtract 5.
On each side. Then you get the 1/3 and the 5, then you multiply by 3 on each side.
Yes. So you
You
get
got
x equals 15.
Yep, got it.
So there are only these many types of, there's only 4 types of two-step equations.
They're
And
they're all in different they're in different ways, I guess, of
yeah, now there's other variations on it. But the point is that like I don't want you to feel like there's this unlimited spectrum or possibilities. Like there's only these.
Yeah. Yeah, now I get it. Like it's pretty much the same thing on every single thing. It's just a little twist.
Right. So if I give you an inequality, and there are some rules about multiplying and dividing and changing it, but if I tell you that it's 2x minus 4 less than or equal to 8, and I ask you to solve this, I'm giving you one of these 4 types.
Yeah.
So I'm trying to get you to buy into this idea that you already know how to do this, because it's either add, divide, add, multiply, subtract, divide, subtract, multiply. That's it. And you already know how to do these. We just went through 4 examples, using them all perfectly.
Yeah.
So this one is an add, because you got to undo that,
You gotta undo that. You add both on each side.
and then divide.
And then divide. Yeah. Yeah, I get this.
So can you solve this one for me, please? Can you
Yeah.
give me your final answer, please?
Okay. Just give me a second. Okay, so you first add 4 on each side.
Okay. Give me your final answer when you're
X is equal 6, or the greater than thing equals 6. Not X.
so here's what I heard. And
Yeah, that.
that is not correct. Okay. And I'm being very difficult because there's differences here. So let's go through these symbols one more time. So this means less than or equal to.
Yeah.
Okay. Do you play any sports?
Yeah.
What sport do you play?
Basketball, swimming, and a skateboard.
Okay. So let's talk about basketball. If you tell if you're subbing in for someone and they tell you that you're guarding 25 and that you really meant 52, would that be confusing to them?
Yeah.
Yeah, and that's what happened here. You said, oh, it's bigger than 6, but you didn't mean that. Here's what you meant. You meant x is less than or equal to 6.
Yeah, that's what I meant.
That's what you meant, but you said that. And the problem is like
I don't know how to say that. I don't know how to say that.
Right, and that's why I want to cover it right here. This is kind of like English class, where they give you a word on one side of the card and the definition on the other.
Greater than equal to. Okay, I see.
This has to be like burned into your memory so that
Yeah, I met with the line under it.
right.
My paper shows that. I just I just kind of agreed with it.
Okay. Let's see what else we got here. I don't like any of these. Okay. Let's try another one here. Let's try another one here. So let's say you got 5 plus 2x less than 13, negative 13. Let's do negative 13 here, okay? So I want you to solve. And as I mentioned before, it's either an add, divide, add, multiply, subtract, divide, subtract, multiply. I move the position of the variable, right?
Yeah.
What's the sign of 5? Is 5 positive or negative?
Positive.
It's positive because of this, not because of this operator here. So you're going to, it's one of these. You're going to subtract 5 from both sides.
Okay, I'm going to solve it right now.
Okay.
Wait, can you go up really quick?
Sure.
Or I have it on my paper. It's fine. Okay, I think I got it. I'm pretty sure I got it.
Okay. Give me your final answer and try and let me scroll up so you see the right words. What are the right words to say?
X is less than 4.
Okay, so what is minus 13 minus 5? That's where the mistake is.
Oh shoot! Oh my gosh. Oh, it's 8. It's 8.
Well, this is negative 18. Minus 13 minus 5 is minus 18.
Oh yeah, because it's a negative. Oh, I thought you like just messed up writing the negative thing on the 13.
No,
I thought
no,
you just
sorry
like did
about
a
that.
line. I didn't put it as a negative. Oh, I see now. Yeah, I thought that wasn't a negative. Okay, yeah, I see. Let me do another one then.
Absolutely. Absolutely here. So I got 4x. Let me change this here. 3 minus 4x equals minus 17. Okay. So again, it's either subtract, multiply, subtract, divide, add, multiply, add, divide. What is the sign of 3?
Uh, wait, what?
What is the sign of 3? Is it positive or negative?
Oh, positive, positive, positive.
Positive, right? It has nothing to do with this. This minus goes with that. So how do you undo positive 3?
Uh, subtract 3.
Subtract 3 from both sides. So this is minus 4x equals what number goes down here?
It is shoot, 20, negative 20.
Negative 20. Okay. How do you undo this right here?
You divide on each side 20 divided by 4. Negative 20 divided by 4. And
Negative 4.
those cancel out. Yeah.
Negative 4. Yeah. So x equals.
Yeah, 5.
All right. Perfect.
Yeah, I just didn't think that was a negative. I thought you just like made a dot on accident when you're drawing.
No problem. All right. I do have another lesson to run to here at this time.
Yeah.
So I'll send you the notes and screen recording out shortly. I'm getting a better feel with what you're how to best help you. I'm probably just gonna have a quick dialogue with your mom just to give her some feedback, but nothing negative. It takes a session or two for me to kind of know what you need to best help you. So thanks again for scheduling, and I'll
Yeah.
see you next time.
All right. See ya.
Have a good day. Bye now.
Bye.